Dear friends, welcome back. In this session, we will understand something very important and very fundamental. You cannot escape without learning this. What is that? It is called A Priori Algorithm, and you need a very clear understanding as in how do we go about it, what are the steps involved in it. All these things are very much necessary for you, and I am going to help you with that. Well, we had this slide in the previous session also. What is this? Association rule mining can be viewed as a two-step process where the first step is involved in finding out all the frequent item sets, and the second step will be involved towards generating a strong association set of rules from the frequent item sets. Well, why are you saying that now, sir? Very simple. For finding out all the frequent item sets, we have got two techniques that can be followed. The first one is called A Priori Algorithm, and the second one is frequent pattern growth algorithm. We will go with the second one a little later, but it's time for us to understand what exactly is A Priori Algorithm and how does it work, step by step. The slide might not be understandable at this point in time, but definitely this slide will make a lot of sense after I complete the example. I'm going to take an example step by step which will make you understand things clearly. But before we go into it, let's read through it once and then let's understand things later through an example. A priori property is nothing but all the non-empty subsets of a frequent item set must also be frequent. You might not be able to understand this right now, but you will definitely understand this after the example. If I1, I2 and I5 is a frequent item set, then all its subsets are also frequent. What do you mean by that? Very simple. One item frequent set I1, I2, I5. This is called one item frequent set. Two item frequent set I1, I2, I1, I5, I2, I5. These three are called as two item frequent set. Three item frequent set I2, I5, I1. These three are called three item frequent set. Now, if I1, I2, I5 is a frequent item set, then all its subsets are also frequent. This is one item subset, this is two item subset, this is given in the question. So, we understand the point that if the given set, this is the data, is a frequent item set, then all its subsets are also frequent. Remember this is called a priori property, which is very, very important. Now, we need to go into the algorithm. I am going to take you through a simple step-by-step process. The first step is to get the candidate set C1 for one item frequent set, one frequent item set. Then we need to find out L1. First, what did we do? We found out the candidate set C1 for one frequent item set. Then we will go with L1. Similarly, we will find out C2 for two item frequent set. Then we will go ahead with L2. Similarly, C3, then L3. And we will go ahead with this process until such time where Lk becomes null. That's called termination condition. All the rules in Lk minus 1 are considered as frequent item sets. So, we will understand this with an example right now, and I have crafted a very simple example by referring many materials. This is a very simple question. It's easy to understand. Right. There are data sets which are given for you. There are data entries which are given for you, which has got 9 transaction IDs, T1 to T9, and each of them has got certain items connected to it. T1 has got I1, I2, I5, T2 has got I2, I4, T3, I2, I3, T4, I1, I2, I4. Likewise, I have got data now. Now, we need to implement or apply a priori algorithm to find out the given task. But before that, every question will definitely have the detail as in what is the minimum support count. The minimum support count is part of the question, and they mentioned it as 2 here. Very simple. We need to now find out C1 L1, C2 L2, C3 L3, and we need to go on until such time where we meet this condition Lk becoming null. And then we will go ahead with Lk minus 1, and that's it. We have found out the frequent item sets. So, we are going to identify the frequent item sets for the considered data set with having a condition minimum support count being 2. That's all. Now, what is the first step? I need to generate C1. C1 has to be generated. How do we do that? What is C1? C1 is nothing but one frequent item set. One frequent item set. Now, how many times each item has occurred in the data set is what we are going to understand. What are all the items available here? I1, I2, I3, I4 and I5. So these are all the items available in the item set I1, I2, I3, I4 and I5. We make a table, and this table is called C1, and the item set which has got the items I1, I2, I3, I4, I5 are listed, and then we need to now find out the support count. Well, what is the support count? Support count is nothing but in the input data set, in the question, in the data set which is given to you, how many times I1 has occurred, how many times I2 has occurred, I3, I4, I5 have occurred. Now let's find out from the given data set how many times I1 has occurred. I1 has occurred once, twice, thrice, 4 times, 5 times and 6 times. So it is 6 here. How many times I2 has occurred? 1, 2, 3, 4, 5, 6, 7. 7 times. I3 how many times it has occurred? 1, 2, 3, 4, 5. And one more time is missed somewhere. 6 times it has occurred. So I made the entry here already. So it is here. So 6 times it has occurred. Similarly, I4 twice, I5 twice. Now this table is called as C1. We have generated an item set with items with support count clearly through referring the data set which is considered, which is nothing but the input data set. Now what is the next step? You have got C1 in the hand. Now you need to find out L1. That's all. You have got C1 in the hand and you need to find out L1. Right. How do we do that? It's very simple. Understand that the given question is very clear all about specifying the minimum support count being 2. So in this table, is there any number which is less than 2? The occurrence of I1, I2, I3, I4, I5. Is there anything which is less than 2? No, it is not less than 2. So we are not ignoring or discontinuing any of these item sets. We are continuing with everything, and the entire table C1 will become L1. If there is some data entry, for example, I4 has become 1 or 0, I will exclude I4 and then I will create a new data set, new data table, and that's called L1. The C1 in this case, since the support value given in the input, I mean the question itself is 2, and we get all the values either equal to or above 2, we can make this L1. Now C1 is generated, we identified the support count and we compare the support count with the minimum support count given in the question. Whatever support count in the table C1 is less than the minimum support count in the question, they are to be ignored. In this case, I do not have anything, so I continue. This data completely becomes L1. So the first step is over. Well, what is the next step? The next step is going to be generating C2. How do we generate C2? L1 joining L1. L1 cross L1 we call it. That's the way we can write it. I am going to generate C2 through L1 cross L1. What do you mean by that, sir? Very simple. I have got L1 in hand, which is taken over from the previous slide. I1 6 times, I2 7, I3 6, I4 twice, I5 twice. Now I am going to generate a new item set, a new table L1 cross L1, which is nothing but C2. And how do we do it? I1, I2, I1, I3, I1, I4, I1, I5. You could see that here. The item set I am creating I1, I2, I1, I3, I1, I4, I1, I5. Now I2, I3, I2, I4, I2, I5. You can see that here. I3, I4, I3, I5. That's here. And then I4, I5. This is called two item set. This is called one frequent item set when it comes to C1. Now we have two frequent item set, and that's what we have created. Now we need to identify the support count. We need to understand what exactly is the support count for I1, I2 in the given data set. So how many times I1, I2 are available in the given data set? Once I1, I2 is available, you can search for it. Second time it is available, third time it is available, fourth time it is available. So 4 times. I1, I3, how many times they are available? I1 and I3 together. Once, twice, and I need to go on like this. I can find out 3 times, 4 times they are available. So it is also 4. Similarly, I need to calculate. Let's see I3, I4. How many times I3 and I4 are available? I3 and I4 are not found anywhere in this, so it is 0. I3 and I5, how many times they are available? I3, I5. Can we scroll it through quickly? I3 and I5 is available only once, so it is 1. Now, based on the input data that we have in hand, we need to understand how many times these item sets have occurred in this data, the input data, and we need to come up with the support count number. Now the input, the question itself clearly says that the minimum support count value is 2. Now we need to compare 4 with 2. 4 is larger, 4 is larger, this is smaller, this is 1, 1 is smaller, 2 is equal, 4 is larger, 2 is equal, 2 is equal, 0 is smaller, 1 is smaller, 0 is smaller. So I will have to now ignore I1, I4, I3, I4, I3, I5, I4, I5, and rest all will be projected as L2. Now what we have done? We have compared the support count that we have derived with the support count that has been given in the question, and we are able to come up this new table, and this table is nothing but L2. So last time we generated L1 from C1, this time we are generating L2 from C2. Now what is the next step? It's very simple. We are going to generate C3. How do we generate it? C3 can be generated with L2 cross L2. What is C3? C1 says that it is 1 frequent item set. C2 is 2 frequent item set. C3 is 3 frequent item set. That's all. 3 frequent item set. So how do we do it? Very simple. I am going to now generate L2 cross L2, which will get me C3. So what do you mean by L2 cross L2? Very simple. I1, I2, I1, I3. Now I need to cross these two. So I1 is common. I1, I2, I3 will be the first entry. I1, I2, I3 is the first entry. Finished. Now let's go to the second one. I1, I2, I1, I5. I1 is common. I1, I2, I5. Let's see if I am right. I1, I2, I5. The next one is I1, I2 versus I1, I5. I1, I2, I5. I have already told you this. I1, I2, I2, I3. Now I1, I2, I3. If you have the entry already available, here it is already available, we can ignore it. You are supposed to ignore it. See that here in the first time when I compare this with, when I merge this with this, I1, I2, I1, I3, I get I1, I2, I3. If I get same I1, I2, I3 again somewhere like this, I can ignore it. Please understand, I will have to ignore it because there is no need to duplicate a particular entry. Now similarly, I1, I2, here I2, I4. So I1, I2 is common, I1, I2, I4. You can see that here all those should be a single time entry. I1, I2, I4 is only one time entry here. You cannot have it the second time. You cannot duplicate. Next, I1, I2, I2, I5. I1, I2, I5 since I2 is common. I1, I2, I5 is here. That's all. Likewise, I will keep pushing the data into it, and remember one point, if at all, if at any point in time, I get the values like I1, I3, I2, I3, forget it, this point won't work, I1, I3, I2, I4, you can take this case. I1, I3, when you join it with I2, I4, you get I1, I2, I3, I4. All the 4 are unique, so all the 4 items will come in picture, I1, I2, I3, I4. But can I take it and put it here in the table? No, you are not supposed to do that because it is only C3. C3 means it has got only 3 item sets. So 4 item sets cannot be part of it. Do you understand? 4 item sets cannot be part of it. Just understand that point. There cannot be any duplication. There cannot be 4 item sets in the 3 item set table. These are all some real very unique point that you need to understand when you go ahead with curating this. Now what do? I need to take the input data. I will start counting. I1, I2, I3, where are they available? I'll start counting it. I1, I2, I3 is available here. It's available here. So twice. I1, I2, I5. I1, I2, I5 is available. I1, I2, I5 is available. So twice. I1, I2, I4. I1, I2, I4. It's available only once. So 1. Likewise, I'll start understanding what are all the number of times of occurrences, which is nothing but the support count from the input data, and I will figure it out. 2, 2, 1, 1, 0, 1, 0. Now, what is the input question condition? The question says that the condition is 2. The minimum support count will be 2. Now, I will start comparing with 2. 2 is not lesser than 2. 2 is not lesser than 2. 1 is lesser than 2. 1 is lesser than 2. 0 is so. 1 is so. 0 is so. So, I will ignore all these 5 data entries and I will take up I1, I2, I3, I1, I2, I5 alone, and that becomes L3. That's all. So, we are ignoring repeats, we are ignoring 4 data set entry, 4 item set entry in a 3 item set calculation. All these are very simple and very important for you to understand. Now, what is the next step? We need to compute C4. We need to compute C4. We computed C1, L1, C2, L2, C3, L3, and now it is time for us to compute C4. How do we do it? L3 into L3. So, I1, I2, I3, I1 is common. So, what do? I2 is common. I1, I2, I3, I5. This is the item set. So how many times does it occur in the input case? You can see that here it has occurred only once. So what do? I'll put support value as support count as 1. I1, I2, I3, I5 has occurred only once, and hence it is 1. So is 1 lesser than 2? Obviously yes. So we will have to stop the condition here. That's all. You have completed the work. Now L4 is nothing but null. You are putting L4 as null, and the moment you get this null in the status, you need to go for L4 minus 1, which is nothing but Lk minus 1. So Lk minus 1 is nothing but L4 minus 1, which is L3, and hence the frequent item set is L3. I1, I2, I3, I1, I2, I5. These are the frequent item sets that can be calculated through the a priori algorithm. So I have taken another example for you, but I think you would have understood very nicely through the example that I gave. You try out more examples, only then you can understand this clearly. I hope now it is very clear for you how exactly the a priori algorithm works. In case you have any questions, please go ahead and type it in the comment section. I'll be happy to answer. If you like the content of the channel, please give a thumbs up and subscribe. Thank you.